Hi, welcome everyone. So in this today's video session, we'll see the steps for writing any Verilog HDL code using this Xilinx ISE Design Suite. So this is for HDL lab for Electronics and Communication Engineering. So myself, Muhammad Ali, I'm working as an assistant professor at Mysuru Royal Institute of Technology. So in previous video, we have seen that how to install the Xilinx design suite. So now we'll start writing the code. So we'll double click on the Xilinx ISE design suite. So it will take some time to open this. So once it opens, the window will look like this. It will give some tips. So you read the tips and click on OK. So for writing any program, first of all, we need to create a project. So we'll create a project by clicking on File and New Project. So it will open a wizard. So here it will ask to give a project name. So I will give example. So you can give any name. So it will ask for the location. So you cannot write any programs at C drive. So that's why we'll change the location. So we'll select this D drive. So in this D drive, I will click on this make a new folder and I will give a name ABC. So you can give any name. So I will click on that ABC folder in this D drive and I will click OK. So you can see that our project location is in D drive ABC folder and a project name is example. So we'll select here HDL. So it has already been selected HDL, so we need not to change that. So we'll click on next. So here we need to give the device properties. So which device we are using. So we will select the family. So as we are working on Spartan 6, that's why we will select on Spartan 6. So it is having a device XC6SLX4 and the package TQG144, 144 pin IC, FPGA IC. So here we'll select, we can see that it has already been selected simulator as iSIM simulator. So we need to select the language. As we are writing the code in Verilog, we need to select this as Verilog. So then we'll click on next. So it will give the summary that a project name is example, a path, and we have selected this device and we are using this iSIM simulator. So this iSIM simulator is inbuilt simulator in this ISE design suite. So we'll click on finish. So this creates a project. So you can see here our project name as example and we are using this IC and with this package. Now as we want to write the code, so we need a source file. So we'll go on to project and we'll select new source. So here we will select the Verilog module and we'll give the name. So as I'm writing code for gates, so I will give a name gates. So it will be in the same location where our project was. So I'll give a name gates. Click next. So here only we can give the inputs and outputs for that gates. So we'll write it in the program itself. So we'll select next and we'll finish it. So once we have taken the source file, so we can see this blank source file. So here it has been, we can see here that for our project for this device, we are writing a Verilog file with the name gates. So here we'll write a gates. So let us take, I will first write a code for AND gate. So we'll first see what is this AND gate. AND gate is nothing but it will perform this AND operation and it will give a output. So we have two inputs and one output. So don't go with this names. So we have A and B as inputs and Y. So we'll take it as Y as an output. So if both the inputs are high, then only the output will be high. So this is the working of an AND gate. So we'll start writing the code for an AND gate. So first we'll define the outputs. So we'll define Y, comma, so inputs A, comma, B. So I will close the bracket and put a semicolon. It was already there, so we need not to write that. Then we'll declare the ports. So for declaring the ports, first we'll declare the output ports, OUTP output. So we have output port Y, so we'll declare that as Y. So next we'll declare the inputs. To declare it, we'll write a keyword input space A, comma B. So these are the two inputs we are declaring. Next, we can write the code in different abstraction levels. So here I am writing the code using data flow abstraction level. So for data flow abstraction level, we need to write this assignment statements. So to write that assignment statements, we will write a keyword assign. Then we'll write an expression. So for AND gate, expression is Y is equal to A and B. So here we have a expression for AND gate. So we know that AND will perform AND operation as this one. So if both the inputs are high, then only the output will be high. So once we have written the program, so we will end this module. So end module is already given there, so we need not to write once again. After writing this program, we'll check for the errors. So whether we have written the program properly or not. To check this, we'll click on this synthesize XST. So here we have a plus mark. We'll click on that and we'll check for the syntax check. So we'll double click on this syntax check. So after writing any program, we need to save. So it is asking to save the program. We'll click on S. So we can save it here. You can observe here in this console window, if we don't have any errors, it will give a completed successfully. So you can see if you have any errors, so we can see it here, number of errors, number of warnings, and we can see it here. So we can drag this one and we can see in a single window, we can see all these things. Number of errors are 0, number of warnings, number of infos are also 0. So let us, I will remove this semicolon and I will save my program. Once again, I will check for the syntax. So here we have missed this semicolon, so that's why it is giving one error. So we can see what is that error. So error is at line number 28, that is syntax error near end module. So here it is telling that we have an error near end module. So before this end module, we have not properly terminate this assignment statement. That's why it is showing the error here. We'll once again click on this. We'll save a program and we'll check. So it will give 0 errors. So once we have checked this program, we need to verify in terms of truth table. See this truth table of AND gate, that is for only both inputs 1 and 1, and then only we'll get the output 1. So for writing this, we'll generate the waveforms. To write that, we need to take one more source file. So click on project, we'll click on new source. So this time we are writing a test fixture, that is, we are writing a stimulus program. That's why we'll click on this Verilog text test fixture, and we'll give a name for this module. That is, I will give gate test. So I can give any name. So this will be added in the project, and we'll click next. So it is asking that, so it is associated with the file gates. Yes, it is associated with the file gates. We'll click on next, and we'll click on finish. So again, this will create a test bench, or we'll call it as a simulation program. So we can see here we have a simulation program with the name gate test, and we have two inputs with a register variable and one output variable, that is with the nets wires. And this gates, so our main program, design program gates, has been instantiated in this gate test program. So instantiation name is UUT, that is unit under test. So here we have instantiated in connection with names. Next, we'll start writing the code. So code will be started with initial, and we'll write begin. So already it has been given, and it has been given default values a and b as 0 0. So for the next values, we need to give a and b as a0 b1 as our truth table, a0 b1. And here this hash 100 gives the delay between these two values. That is, so we'll copy this and we'll paste it for another 2 times, 3 times. So we'll change the values 0 0, and this will be 0 1, this will be 1 0, and the last last values are 1 1. In between these, we have given 100 time units delay. Right. So we'll check for this program whether it is written properly or not. To check this program, so we need to click on simulation. Remember this, we need to click on simulation. So here you can observe that, so we have get gate test as a file name. So under that we have a UUT of gates. So that is, in gate test we have instantiated the gate file. Right. So we have a gate program, this one, and gate test, this one. Right. So we'll save this gate test file, and we'll click on this gate test and click here and the process. So we'll check for the behavioral check syntax. We'll double click on this behavioral check syntax, and we can observe that it has no errors, and it is syntax check is completed successfully. Next, we'll click on this to simulate this program. We'll click on the simulate behavioral module, double click. So it will take some time, and it will open one more window, that is ISIM simulator window. So we can give cancel for this. So we can see here, this is our ISIM simulator window. So we'll expand that window, and we can see here the waveforms. So to view all the full waveform, so we'll click on zoom to full view, so we can see the full waveform. So here, so we can observe that A and B are 1 1, output is also 1. So we can click anywhere on the waveform, and we'll check A is 0 and B is 0, output Y is also 0. So we'll click on here, A is 0, B is 1, output is 0. Here A is 1, B is 0, and Y is also 0. So at this time, so A is 1, B is 1, hence the output Y is also 1. So thus we can verify that what we have written a code, whether it is perfectly written properly or not. So we can write program for any gauge, any design, and we can check it in this iSIM simulator. So once we have done with this programming, so we can close this iSIM simulator. So we can write more programs by clicking on project, new source, and we'll select Verilog module and we'll give a name. So I will give a name as all gates and I will click next and finish. In this all gates, I will write a code for all the gates. So let us take all the gates, AND gate, OR gate, NOT gate and XOR gates. Let us take and write for these 4 gates. So I have got this program and out I have taken as output for AND output, OR out for OR output, NOT out for NOT gate output, XOR out for XOR output, A and B are inputs. So I have declared this outputs as AND out, OR out, NOT out, and XOR out. So inputs are A and B. So I have assigned this AND out is equal to A and B, OR out is equal to A or B, NOT out is equal to NOT of A, XOR out is equal to A XOR B. So we have written a code for 4 gates in a single program. So we'll verify this program. So before that, so we have two programs here. So first, this program, gates program. So we need to remove this gate program and we'll left out with all gates. So in this all gates, so we can see here we have 3 dots here. So that gives which program is actually running. So we'll click on that and we'll check for syntax. We'll double click. It has asked for to save the program. So we have given yes, and we can see here we have 0 errors and no warnings, no infos. So our program is completed successfully. Now we'll write the test bench, that is a simulation program for this. So we'll select this Verilog test fixture and we'll give a name all gate test. We'll click on next. So it will ask for which program we are writing this test bench simulation program. So we are writing for all gates. We'll click on next. We'll give finish. So automatically it will give the program. So we can observe that all the outputs are declared as wires and inputs are declared as registers. And we have instantiated all gates as a name UUT and we have given the inputs and outputs. So let us take, we'll write the values initial, begin, and A value, B value is initially 0. So we'll write uh, for 4 combinations of A and B. So first combination is 0 0, second will be 0 1, third will be 1 0, and fourth is 1 1. So we'll save this program and we'll click on the simulation. So we can see that we have already all gate test. We'll click on that all gate test and we'll check for behavioral check syntax. So we'll double click on that behavioral check syntax. We can see that we don't have any errors. So we'll click on this simulate behavioral module. So it will open with an iSIM simulator. So we can see here the waveforms. So I'll click on this, zoom to full view, so I can see all the waveforms on the screen. So first we'll verify at the first position. So we can see here A and B are 0, AND gate is 0, OR gate is 0, NOT is 1. Because so if A is 0, NOT will be NOT of A, that is 1. So XOR is also 0. Next, A is 0, B is 1. So 0, 1. For 0, 1, AND is 0, or is 0, 1 is 1. So we can see here OR gate 0, 1 is 1. So like that, we can verify for all the combinations of the inputs. So for 1 1, so 1 1, and output is also 1, or output is also 1, not is 0 because A is 1, A not of A will be 0. XOR, for XOR operation we can see here. So if both the inputs are different, that is 0 1, XOR out is 1, and for 1 0, XOR output is 1. So if both the inputs A and B are 0 0, XOR is 0. A and B are 1 1, XOR is also 0. So you'll see the other designs in the upcoming videos. Like this video and subscribe my channel. Thank you.